Okay. Uh, when I started my career, I was working in robotics, and you had to be techno savvy to that do robotic. And man, I was on it, man. Jeez, I don't know. I'm getting old, I guess. Okay, so anyway, recording now. You'll have the iPad. That will be there. And you won't. But anyway, so,
confessing that I didn't know how to do it. But anyway, okay, so let's see. Get this out of the way. I'll make it about 300% so you can be able to see it better.
I do. Okay. Have it down. So, what's the first thing you do? Taking an exam with. So,
what's the first thing you ought to do?
You should quit because it says everything done.
You should quit.
Start fresh. You may have been doing something else. All of a sudden, remembers
start fresh because you may have been doing something else.
So do that. And then I'm going to put the equations. Like so, like type of an equation equals y1
cosine. I like to do it like this. I like to type an equation equals y1.
Because I'm saying I'm going to call it EQ. And so whenever I say EQ, I'm going to call it
this stuff. I'm going to call it EQ.
So it's one. Now it's a set of things that I've just typed in. So I use the brace. I like to just drop them. You don't have to, but I like to
use a curly brace.
So I'm just going to type in the equation. And I can see them from the iPad, so trust y. Z, y, it's an equation. One of the most common mistakes you'll make, especially under duress on exam, you'll forget to equal, and then it'll freak out. Okay, equals equals, and it's -0.04 times. I'll put in the star. You have to x squared. Is that good? Okay, comma. Second equation says x equals e 10 times capital C because it's built in. It knows what cosine is, right? So COS bracket 30 degrees, right? So I say 30 degrees.
Right? So I'd say 30.
Okay, so it's always radius. That's the pain in the neck. Okay, so
it's always in radius.
Let's see, time T.
Okay, so let's see, time.
Notice T star. You don't have to. You just have to put a space in it, right?
Notice I didn't use a star. You don't have to. You just have to put a space in it, right? Just put a space in there, and then it'll say, oh, yeah, you
is y equals
okay,
10.
And the last one is y equals
10 cosine. Oops.
10. Whoops.
Sine.
10
Sine.
Cosine. Oops. Sine.
30 degree
of 30
T minus
degree
1/2
times T minus
times 3
1/2 times
out exactly
322 divided by 10. I'm going to have it come out exact, right?
Squared. That's all.
32.2 times T squared. And that's all my equation.
You can't. It'll be yeah. I'm just trying to show off. That's all.
And then it'll be a number. And I'm just trying to show off. That's all.
And it comes back. This is what I think you said. And I look at it, yeah, that's right. And if you notice, if I had this point right here, 32.5 times 32.2, this would have been 5. That's almost. Okay. It's do it this way, just like your math profs. They like to do everything with fractions. Right? So anyway, so now what do you want to do?
So anyway,
solve. How do I solve?
Now what do you want to do?
You say solve, right? With capital S. So you say, okay, solve.
You say solve, right?
What do you want to solve?
So you say, okay, solve.
EQN. You could type it all in.
What do you want to solve?
Say
EQN. You could type it all in there.
What do you want to solve?
You say
Y.
Solve the equations.
X.
What do you want to solve for?
T.
Y.
You know, if it was so smart, it doesn't know that.
T.
I don't know.
You know, if it was so smart,
there you go.
How
Why are they?
I don't know.
It's quadratic. There should. Which
What
one
are
are
the
you
two
going to
answers?
Second. Right. Take the second. How's that? Is that good? Oh, you know, the reason number is.
How's that?
0.04.
Oh, you know
so
what?
That, I just
the
the world is
0.04.
yes.
I just
How's that? You want to see the? So if you plan to use mathematics, guys, you must. Right? Okay. I'm going to. Here's how I do it. What I do is come in there and I say, all right, make up a problem. This is important. So I make up a problem. Then I make up another one, whatever. Right? Then what I do is come back. I've kind of forgotten about that. And then I stop watch and start timing. And I solve like boom, 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 all the way through. And I see how long it takes. Then I have a magic factor that I multiply my time by this factor. Say that's how long it takes to do it. Now, I've been teaching for over 30 years. The factor works. Okay, I don't tell you what it is. It's a big number. You say, oh my goodness, I'm really dumb. If it's a small number, you say, oh my God, I'm going to panic. Do that, right? So if it's a number, it works. So about 75% of you will be able to shoot. You say,
so about 75% of you will be able to finish it.
But you will feel like, okay, I could have done that, right? So that's what makeup saying is. Now, what I'm telling you is, if I make up a problem, I'm going to use mathematics on it. Okay? You don't have to, but I am. Okay? Okay? So I'm going to type it carefully, slowly, boom, take my time, not rush through it. But that's what I'm going to do. So if you want to be able to solve the equations quick, and you want to be good at mathematics, okay? If you don't, then it's on you, okay? Yeah, you have to show the. Yeah, the question. I don't have to zoom in. Hold more. So is this? I don't have to zoom in as much. So is this? Show off and show that it would come out as symbols instead of numbers. But then I forgot I had 104, so let me do this. Just to show you what I was trying to do. 4 divided by 100. So now it's do exact arithmetic like your math do. See, now everything's fraction, no decimal, and then when you solve it, you'll do it that way as well. You see? And then when you solve it, you'll do it that way as well. And then, oh goodness, what? And so this number, and then you go, oh, I forgot. Goodness, what? And so divide capital number, man. And it'll give you. I forgot. So you can do this. It wants to divide capital. If you put anything with the period, the object, it'll do it all. If you put anything with a okay. Any other questions? Yeah.
How would you put? So you didn't have Greece. Any other questions? Okay. How would you put that on that?
Okay. Here's what I usually do. I say, okay, I always get angles, right? So I say angle is 30. Okay, that's degrees. I need in radians. How many radians are in a degree? You know, version? There's pi radians and 180 degrees. Right? So I'm going to multiply by pi over 180. So I'm going to multiply by pi. Okay. There's your angle. Okay. And then here, put. There's your angle. Angle. A-N-G. Does that make sense? Right? 3 is built in. So you don't have to that whether you not have it. It's there. It knows what it is. You don't have to. Okay. So. It knows what it is. Okay. Will it find data? Yeah. Oh, you want to think simple thing? Okay. There's something up here in these pallets that, if you like to click, drag, drop, and all that kind of stuff. If you pull up the pallets, it has some. I don't. Okay. But here's how I do it. I do escape. Q. Escape. Okay. But really, if like me, I try to teach where students can read them and go, okay, got it. But if I were on the exam and say data equals, I'd say something like data, I'd write it out rather than trying to remember it's escape, Q, escape. But it's up in those houses somewhere. I don't use use those
But it's
because I
under
click drag on it.
palettes somewhere. I don't use those.
How-
'Cause I hate click, drag, drop.
What do you think?
Okay. How would you do an alpha?
Alpha. A, just A,
What do you think
escape.
letter would be for
How
alpha?
about beta?
A.
B, escape.
A, escape.
B, escape.
How about beta?
What if you want to capital
B,
beta?
escape. B, escape.
Escape, shift, Q,
What if you
escape.
want a capital beta?
Okay, but you don't have
Escape, shift,
fancy.
Q,
It only
escape.
one. Say TH is theta. Okay, as long as you know it's theta, that's good. All right.
Say T,
Anything else?
theta. Okay, as long as you know it's theta.
Okay, I'm going to say that is, and then I'll post it. But you read it. You know, all this
Okay, I'm
is
going to go ahead and save it as
playing
it
around.
is, and then I'll post it.
Okay, file, save,
This is playing around.
and
Okay, file.
oh yeah,
save,
okay.
and, oh yeah, I had a quiz.
Okay, this is September 10th.
Okay, this is.
All right, what?
September.
You want to take this right?
All right, what else? You want to do?
Anything else?
You want to take
Because I'm going to go polar coordinates.
anything else on the home?
No.
Because I'm going to go.
Okay.
polar
If you do, send me an email, post it on
No.
Blackboard, do something.
If you,
where
if you
I'll be
do,
happy
send
to try to
me
do
an
it
email,
and then post.
Blackboard, do something
Okay.
to where I know
All
I'll
right.
be happy to try to do it.
All right.
Post
So
it. Okay. All right.
let me
All right.
let me cover
so,
the polar coordinates because I've got to do that sure. Okay. No.
Let me
order
cover
for you to
the
finish your
polar coordinates. Got to do that.
so,
sure.
what
After you
did I
finish
cover
your homework.
last time? Y'all remember?
Tangent.
Tangent.
What did I cover
Okay.
last time? Y'all remember?
So this is going to be similar. It's polar coordinates. What's going to happen is we're going to use polar coordinates for this. You don't necessarily have to know where the path is. You do have something about how the thing's moving. So this would be the polar. I think your book calls them polar. That's what I call them, polar.
This would be the polar.
Oh,
book calls them.
of course I'm.
That's what I call them. Polar.
Let's see. There we go.
Oh.
That's an O. Polar. Okay, so what happens is you got particles moving up here on some path, right? And
So what happens is you got this particle. And
there he is. There, that's the guy. That's the car, the truck, whatever I have to him.
There he is.
And what I'm
That's
going to do is draw an origin down here, okay? And I'm going to have a horizontal component, so that's my X, Y, and things like that for good. That, right? If you don't, or if you use X, Y, what you do is you can have polar is an angle. So what you do, very first thing you do
and polar is radius and an angle, right?
through the
So what you
like
do
I
is
did.
the very first thing you do is draw a line
That's the
from
first
your
step.
origin through the
Got it.
particle, just like I
Okay.
just did.
Then what you do is you say, oh,
First
that
step.
is direction.
You've got to draw that line.
That is, yeah,
Okay.
it uses
Then
U,
what you do is you say, okay,
R.
that is
It's the
a
radius direction. So if I
that is
say on
the, I
the
think
exam,
it
draw the
uses
radius direction, what are you going to
R. That's radial direction. So if I
You're gonna
say
draw
on the exam, draw the
line
radial
from where to
direction,
where?
what are you going to do?
Or just like the particle points out,
You're going to draw a line
always
from
points
where
out.
to where?
Okay, from the
Origin
that's the
straight to
positive
the
direction.
particle, and it points outward.
Then
Always
what's going to
points
happen?
outward
You got in the second direction.
from the origin.
It's like there's X, Y. There's two directions here.
Then
The way
what's
you
gonna
write
happen is you gotta
it is
find
the same way
just like
every
there's an X
single
and a Y,
time.
There's two directions.
Okay, and rotate
The way
90
you find it is
degrees
the
off
same
the
way
UI.
every
90
single
degrees.
time.
Wait,
Okay, you're gonna rotate
wait,
90 degrees
there
off of the UI.
and you
90 degrees. Which
okay,
way? Here's what you do.
okay. I don't
There
care
will
the angle.
be
This
an
is in the
angle that you are
this is
using
for
to
example.
measure the position.
It
Okay.
could be
I
right
don't
here,
know where
right?
the
And you
angle
could
is.
say
It could be
that's
in another
angle
place.
theta.
For example,
Maybe you know that.
it
Maybe
could
you
be
want
right here.
at it, whatever
You
it
could
is.
say that is
What you
angle
want to do
theta.
is say,
Maybe you know that
angle
Maybe you want to know that
theta
angle.
positive.
Whatever
Well, it
is.
looks to me like it's
What
positive.
you want
It
to do
goes
is say which
counterclockwise,
way is the angle theta
right? Because it's being
positive.
measured here
Well, it looks to me like it's positive. It goes
up to
counterclockwise,
here.
right? Because it's
Isn't that right?
measured from here
Okay, so that's a positive angle theta.
up to
It goes from that x-axis all the way around.
okay.
Counterclockwise is
angle
positive
theta.
direction.
It goes from
You
the
rotate
x-axis
90
all the way
degrees
around.
positive direction. You are. So in that case, I'm going to go 90 degrees from here.
90 degrees.
Boom. That's theta. It's all that direction.
In that case, I'm
Got it?
90 degrees from here. Boom. That's your
U theta.
Always that direction. Got it?
I think the book calls it transverse. Okay, they got to have a big name for everything, else they're not feel important.
I think
Okay,
your book
but
calls
that's
that
transverse direction. Okay,
They gotta have a big
let me give you the
for
quiz.
everything or else they don't. That's
Here's the
a trans-
sky. There's that particle. Here's this one. Boom,
Let's
boom.
give you a little quiz.
Okay, where's the radio?
Here's the sky. There's the particle. Here's this one.
Okay, that's the easy one.
Okay.
Boom, here we go. I'm going to
Okay,
use
that's
this
the
angle
easy one.
right here.
Boom. There
I'm
you
going to call
go.
it alpha.
I'm gonna measure this angle
Where's
right
the
here.
theta?
I'm gonna call it alpha.
Does it go?
Where's the U theta?
Does it go this way?
Does it go?
Or does it A or B? B. Here? It goes down, right? How do well, because we alpha. So measured from where?
How do I
From the
know?
Y
Because which way is positive angle?
over to this line. From here over to here.
Measured from
That's the
where to where?
positive direction, right?
From the Y
That's
over to the
clockwise.
line. From here.
See that? So I'm going to go 90 degrees clockwise from the UR.
That's clockwise.
So now your positive direction is this way.
I'm gonna go 90 degrees.
That's the
clockwise
U theta.
from UR. So now you're
So the direction of theta depends on where you measure your angle.
that's the U theta
Is
direction.
that clear? Okay.
The direction for theta
Now,
depends on where you
I want a derivation.
Clear?
No? Good.
Okay.
Okay. These things can be defined. You just
No.
didn't want a derivation. If you do it in the
These things can be
you do?
defined.
Okay, come by the office.
You just admitted
Okay.
derivation.
If you write position, differentiate,
Come by the office.
you will get the velocity. Derivative of position equals velocity.
Right.
It's a little bit complicated. Your book talks about it. If you really do want to see it, come by. I can do it. It's not like I can't, but
It's a little bit
I know that most of you could care less, and it doesn't help solve problems. So here's the answer that I'm going to get. I'm going to find out that the velocity of this guy is equal to r dot.
I'm going to find out that the
What is that?
velocity of this guy is
Time rate
equal to
change of the
r dot.
r, which is the distance. I should find that right. That's the distance from the origin to particle.
of the
That's r.
which is the distance. I should have defined that, right? That's the distance.
Okay,
from
r
the
dot
origin to particle.
in the r
That's
direction,
R.
just like there's the x and y and
Okay.
I and the
R dot
j.
in the
It's got that
R
much
direction,
x plus
just like there's X and
R
Y and I and the J.
theta
It's got
dot
that much in that direction.
in the u theta.
R.
Now, if you're
Theta
calling
dot
your angle alpha, then
in
the
the
alpha,
U theta.
whatever is your angle, it's the derivative.
Now, if you're calling
Of
your
a
angle
so
alpha,
I got-
well, then it would be alpha dot.
Okay.
Whatever is your angle,
The acceleration, you don't
derivative of the
have
angle.
derivation for that either, right? But the acceleration, the result of the acceleration looks like this. Acceleration
you don't want
equals,
derivation for that either.
let's see, I'm working off of
The
memory.
acceleration, the
This-
result of the acceleration.
This is
looks
r
like
double
this.
dot.
Acceleration equals,
Whoops.
let's see,
Double
I'm
dot.
working off of memory.
Come on.
This is R double dot.
Minus r
Whoops.
theta dot
Come on.
Come on.
Minus
squared
R
in the
theta dot. Come on. Squared
plus
in the
Two.
UR
r dot
plus
theta
2 R dot
plus r theta
theta
dot
dot
dot.
plus R theta.
Okay, that's a complicated one. I can write that down. Okay, those are right.
Okay, that's a
One of
complicated
the things
I
that
would write that down.
you can do it helps when you have equations like this. You're not sure if you've done it right.
One of the
Is
things
count
that
the
you
number of
can do,
dots.
that helps
Velocity
when you have
terms,
equations
all
like this,
velocity terms should
if you're
have
not
one
sure
and
if
two.
you've done it right, is
Dot,
count the number
okay?
of dots.
So look at the velocity. You see the dots?
All velocity terms should have one and only one dot.
This guy right there.
Okay.
There's a
Look at
term.
the velocity.
How many dots?
See the dots?
One. How about this guy? How many dots? One. Okay.
It's a term.
It's not confused, but you could have
How about this
instead
guy?
put a negative,
Dots. Okay.
right? So it doesn't say, oh, sure, right. But sometimes you'll be in the middle of college and say, well, it's not a dot, and then you did something wrong. Now, the problem's going to be simple enough. You don't need to worry about something. When you get out of practice and you do something like this, they're never going to give you an easy problem. And there's never going to be somebody who says, oh, no, you just made a mistake here. No, if you make a mistake, it's going to cost somebody money or maybe his life, right? And you do enough of those, and you will lose your job, right? So what you want to do is you want to have the trick you can to say, this can't be right. I'm not going to turn this in until I find my mistake, okay? How many dots here on the screen? How many here? I'm not going to turn this in until I find my mistake. How many? It's the square term. So theta dot theta, right? So there's 2. How about here? In the term, 2. How about here? 2. Right? So each path is that. Okay? That's something that how about we do? Okay. Maybe it'll help you with the 2 notes. Let's see. Okay. Yeah, I actually hold it up. There we go. How about 167? How about 167? The car travels along the circular curve. Car travels on a circular curve having a radius 400. At the instant shown, angular rate of rotation is theta dot equals, which is decreasing at the rate of theta double dot. Determine the radial and transverse components of the car's velocity and acceleration and sketch the components. Okay? Now, I'm going to give you an exam. The exam may use X and Y. It may use normal. It may use our data. Right? Here, the thing in this section is going to be our data. On my exam, you're not going to know. So you have the first thing you're going to have to do is figure out if you use X, Y, tangent normal, or our data. Now, what I would do is rule them out. Okay? Sometimes, okay, and if it's obvious, you say, look, I don't know why I spend time on that, but oftentimes it may not be obvious. I'm going to tell you how I choose which one I'm going to try first. Right? Okay, first thing I look for is maybe it's tangent normal. Okay, those are the most rare I have found in the real world. Right? What do you know in order to use tangent normal? Remember what it was in the lecture last time? You got it. Got it. Step 1. Oh, okay. Do I know the path? Circle. Radius 400. Yes, you do. So circle radius 400. I know the path. Okay. Bless you. Think about the equations for the tangent normal. What kind of things into those equations? You're going to write them down. Eventually, what kinds of things go into those equations? Yeah, speed. You're going to write them down, right? So eventually you'll be able to look on your notes and say, yeah, it's the radius. Right? Do you know? Yes. Speed. I do. Do you know speed? Radius. You do? What's the speed? Yes, I do. Do you know the speed? What's the speed? I know theta dot. I know the speed. That's not speed. What's the speed? Right? That's theta dot. That's not the I don't know the speed. Yeah, sure. It's not speed. Speed. Right? That's how much the angles change. I would say, well, rule it out. Yeah, sure. You could figure out the speed, right? But it's not given. Rule out. I would say. Does it want to know speed dot? No. I'd rule it out. Don't use it. Okay. Second thing is for R. Okay. What do you need to know? Okay. Second thing you do right up there for R theta. Okay. What do you need theta in order to do R? You need R. They're right up there on the iPad. What else? R dot. You need theta. R double dot. You need R. Theta double dot. Do you R dot? You have those?
Double dot?
Hot dogs, do it.
Theta dot?
Right? It's pretty obvious, right? I mean, all of
You have those?
things given to you, you say, man, that's
Oh,
obvious. But I don't know why he's beating a dead horse, okay? Because I just won't know, right? That's the process I use when I decide what coordinates is. Okay, let's do it. Okay, I'm going to skip to a new page. You might want to find this equation in your book, or trust me, I'm going to identify it. Okay, here we go, page. Okay, we're doing problem 167. All right. It says, determine the rate transverse of the car's velocity. Okay, here we go. I've decided it's orientated. So I'm going to write down the equation. V equals R dot U R plus R theta dot U theta. Okay? All right. V equals, what's R dot? Why is it? Why is R dot? It's a circle. The radius doesn't change in a circle. What's the change? No change.
It's a circle. The radius
R
doesn't change in a circle.
Got it?
What's the change in R? No change. R
U
dot is 0.
plus, what's the R?
0.
4
UR.
feet.
Plus, what's the R?
What's theta?
400 feet.
0.025.
What's theta dot?
And that'll be in U theta.
0.025.
Okay, can you solve that?
That'll be in the U theta.
Yeah,
Okay, can you solve that?
400.
Would you use Mathematica?
Right? Math.
I would.
Mathematics
I'd
is
pull out
cool.
my
It shouldn't
calculator,
be.
take 400 times 0.025.
Okay. So, whatever tool you need, I can. You can probably
torture.
in your head, right? Isn't it? Let's
So,
see, 4 times 0.500, 30.
you could probably do that
0.1.
in your head, right?
Right? Whatever you need.
Times 0.5 is 100.
Okay.
30.
And it's okay. So I need to sketch.
Whatever tool you need, right? Okay.
Okay. So here we go. Here's the circle, circular path. Here's the origin where everything's being measured. Where's the car?
Here's the circular path.
Straight up here.
Origin where everything's being
Okay.
measured.
Need to find the theta. How do I find the theta? What do you do first?
Okay. I need to find the theta.
Draw the arc.
How do I find
First thing you do is the arc. And when you get some just I know what it is. Get away. Just get away. But until you get good at it, step one, draw the arc.
I know what it is.
Zoom. There's the arc.
But until you get good at it,
It's UR.
draw the arc.
Now you rotate 90 degrees. In which direction? Well, you tell which is positive.
Now what? Rotate 90 degrees. In which direction?
See that?
Can you tell?
They're trying to tell you. Counterclockwise. That's the way they're measuring their angle. See that? Okay. Which way is positive? Counterclockwise. Where does U theta go?
That's the way they're measuring their angle.
Right or left?
See that?
Goes left.
Okay. Which way is
Right?
positive?
Take 90 degrees
Which way is
counterclockwise. Right there. There's the U theta.
Goes left. Right. Rotate 90 degrees.
Okay, so where
Counterclockwise.
is velocity? Velocity is right here. There's the car, and he's equal to 0.1, and he's going in U theta direction. So he's like that.
Right here. Here's the
0.1.
and he's equal to 0.1.
So I now
Going in the U theta direction. So he's
is that tangent to the path?
0.1. So now
How do you find the tangent? Here's the path, right? This guy right here. Isn't that the path?
How do you find the tangent? Here's the path.
Yeah, that's the path. Circle path. Doesn't look like a circle. Okay, and it's right there at the top. What's the tangent there? Horizontal. Is the velocity tangent to the path? Yes. Velocity. Always tangent.
Is the velocity.
It might be along the path he's going, or he's in reverse, going backwards, right? But it'll always be tangent.
It might be
Always always. You don't know what path he's going. Find out what direction he's going. That's the tangent. Wait a couple seconds. Find out which direction he's going. Plot that. That's the tangent. You can probably connect the dots and find out what path he was on. Make sense? Always tangent to the path. Okay. What is v? The speed. That's the magnitude of his velocity. What's the speed? It's on the iPad. 0.1. Speed is 0.1. It's tangent to the path. So now it almost looks like I could use tangent normal, right? Because now I know the speed. Ha! So I could change. Listen. Right? But you could, right? Now you know the speed. You don't know the speed not yet. But you do know the speed, right? Any questions? Okay. How about we accelerate? Yes. I in my head, I did. I multiplied 400 times 0.025. Did I get it right? Did I get it right? Oh, answers. I go to be smart ass, right? Okay, so what is the answer? 410? Okay. I knew. I was just waiting for you all that. So this is speed is 10. How's that? Why do you let me get away with it? Now it's recorded forever. Yeah, you see it. Everett's video. Whatever. Okay, let's get acceleration is. I'm going to write it down first. It's r double dot minus r theta dot.
Acceleration is.
You are.
Write it down first. It's r double dot.
How do you know it's a square? Because you got to memorize. This has got to be dots. So you know I've made a mistake, right? So it's r dot r theta dot squared plus. Let's see, 2 r dot theta dot. Write this one down on the sheet plus r theta double dot. I think the hardest thing in these is just writing the equation. U theta. Okay. What are we going to plug into? Okay, acceleration equals.
What are we going to do?
What's our double?
I'm going to see if I can plug into this. Okay, acceleration equals
0, right? R is constant. R dot
what's our
is
double
the
dot?
derivative of a constant. 0. 0, 0, 0, 0 forever. What's the change in 0? Nothing. R double dot is 0.
The derivative of a constant, 0. 0, 0, 0, 0 forever.
Minus
What's
R.
the change in 0?
No, R's not 0. 400 feet. 400.
Minus, what's R?
What's theta dot?
No, R's not 0.
0.025. 0.025
What's theta
squared
0.025
UR plus
0.025
2 R dot 0
squared
times theta dot 0.025
2 R dot
plus
is 0
R is 400.
times theta dot
What's theta double dot?
0.025.
Yeah, negative. Oh,
R is
okay,
400.
negative 0.008. That's not 400 minus that. That's 400 times
Yeah,
that.
negative. Oh, okay.
And that's
Negative 0.008. That's not 400 minus that. 400 times that.
Okay, so let's see. 400 times 0.025 squared. I'm not even going to try that. It's 10 times 0.025.
So
0.25.
400
Did I get that right? 0.25?
0.025 squared. I'm not even going to try that.
You're not
It's
going to
10 times 0.025.
0.25.
That right?
0.25.
0.25.
That'll be the UR.
You're not going to. Point.
It's a theta dot. Right
That'll
here.
be the UR. It was. It says theta double dot.
Let's see. Plus, minus 408 times 4 is 32. So that'd be boom.
Plus
3.2.
minus
Get that one wrong?
408 times
Okay.
4 is 32. So that'd be
Yes, it is. Thank you very much.
Did I get that one right?
And minus 0.2.
Yes, it did. Thank you very much.
Now they want
Minus,
to sketch,
3.2.
right? So what I'm going to do is going to say, okay, I've got the diagram right there,
Now they want to sketch.
right? So don't redraw it. So where's the
What
UR?
I'm going to do is I'm going to say, okay,
Points up.
I've got the diagram right there.
But this is negative,
Right?
so it's going to go down,
Redraw it.
right? So this guy needs to be
Points up.
the 0.25 down this
This is
way
a
at
negative.
point
So it's going to come down.
2.5.
Right? So this guy is
The U thing, that is left,
0.25. He's going to get
but he's negative,
at point.
right? Negative. Which way does it go? To the right.
The U thing, that is left.
Through
Negative.
3.2. Okay.
Go
And
to the right.
yes. What is the acceleration?
3.2. Okay. Now let me ask you.
3.2. That's the tangent direction.
What is the
Right.
tangent?
3.2 is speeding up, slowing down. Slowing down because he was going 10 to the left.
Right.
He's accelerating 3.2 to the right, slowing down. Right? If you wanted to be precise, you'd say he's decelerating. Decelerate simply means you're slowing down. Accelerate just means that you're changing your velocity. That's all it means. Right? So like everybody in this room is a human.
Accelerate.
You are right. Okay. Everybody in this room is a human. Some of you are male. Right? So that's like, this is an acceleration. It happens to also be a deceleration. Got it? Okay, so deceleration simply means going. That's it. Okay. Acceleration could mean going faster, slowing down, which means you're changing. Acceleration. Yes. Okay. What is the 2.25? What's the normal component of acceleration? Where's the tangent? You know where the tangent is? Right? There's the tangent.
What's the
Where's
normal?
how do you find the normal? You go 90 degrees.
Where's the
tangent?
You know where the tangent is, right?
Inward.
Where's the
Right?
normal?
Always inward. So where's the tangent pointing out? Is this the tangent?
Off the tangent.
Folks, get this tangent.
Inward.
Sorry,
Right?
that's the tangent.
Always inward.
He's going down. It's like the left. If he was traveling to the right, tangent go to the right. The tangent always goes in the direction.
That's why it goes left.
Okay. Then you take 90 degrees off. Tangent. Off.
Always goes in the direction
Inward.
you are moving.
Which way is it?
Okay. Then you rotate
Down.
90 degrees off.
So is this guy normal
This guy. Inward.
or is he negative normal? He's the negative of normal. Okay. So what is the normal acceleration?
Or is he negative?
Is it negative? It's
Okay.
0.25. The normal acceleration is 0.25. Got it?
Negative.
What's the radial
It's 0.25
acceleration?
inward.
Radial acceleration.
The normal acceleration
Minus
is
0.25.
Got it?
What's the
radial
normal
acceleration?
acceleration?
Radial
Positive
acceleration.
0.25.
Minus 0.25.
Right? Positive 0.25.
What's the normal
Is the
acceleration?
normal acceleration
Positive
ever
0.25.
negative? Think about
Right?
the formula. Normal acceleration is normal.
Is
The formula is
acceleration
speed
ever negative?
squared divided
Think about
radius.
the formula. Normal
Is the
acceleration.
speed
Acceleration normal.
positive be negative?
Plus speed
Square it.
squared
Positive. Always.
divided by radius.
What about the radius?
Is
It
the
had a
speed
negative.
positive?
Nope. Always positive.
Negative.
What's the radius?
Square
The
it.
normal
Positive.
acceleration
Always positive.
ever
What about the
No.
radius? You've ever had a negative radius?
is the
Nope.
radius.
Always positive radius.
Alright.
Is the normal
negative.
acceleration ever negative?
Oh, come on.
No.
Is the radius
Is
acceleration
the radial
I don't see. So the radius can be negative, but the normal is never. See if this possible. Okay. Let's say you're driving This is getting chapter, but I think you can do this. Y'all equals force equals mass times acceleration. Okay. So you drive your okay, it looks like my piece. Okay, you're driving. I'm doing 9 miles. And I turn right, left, like this. Which way? It's inward, facing, turning left. Okay, so they're fine. Okay, where's the force? Why is this? Right? But Newton's F equals ma, CA. How come F is? It is. It is. Imagine you're okay, and I vinyl flat, whatever. You got no. You got no. I got no. I have a door. Okay, door's closed. I hang a left. What happens to you? Don't you go like to smash up the window? Okay. Okay. So where's the right here? No, is touching and pushing you away in that way. Right. Force is that way in the direction of acceleration. What do you feel? You feel like you're. What your body's telling you is you always feel the opposite of what's happening in your acceleration, and that's going to confuse you class. Because you're going to say, "Oh, it can't be that way." Because, I've been done it, and I feel it doesn't matter what you feel, because your body always feels the opposite of what's really happening to you. You're in a jet. It's not. Okay. You're in a jet into the runway. Okay. Hit the metal. Your weight is like you're thrown backward. Is that what's happening? No. Seat is smashing on your back and saying, "Come on, stay with the airplane." So your force is that way. Your acceleration is that way. See that? So what you feel is the opposite of what's really happening to you. Okay? So in this particular case, you're hanging a left, your acceleration is down. There will be a force pulling you downward. If you don't have enough tire force on your tires, right? If you don't have enough friction on your tires, which way is the car going to go? He's going to go straight off that way. You never go inward, right? So you're going to go off the road that way. Why? Because you don't have enough force to keep you on this circle. You hit ice, no friction. And he said, "Well, I don't have a force. I'm not going to accelerate." Off the track. Got it? Okay. Let's see if I got my iPad back or not. Nope. I don't know what this thing works everywhere. Here, huh? Okay. I still have some. I want to do another problem. I'll do one more. Okay. I'm going to stop the recording because what's the point? Pause.